Today we will distribute a monomial through a polynomial to simplify the expression. In our process with dealing with exponents, we're going to be stepping it up from our basic multiplying by a constant to terms where we have a variable along with it. And this is going to change up what we first went over the first time we talked about the distributive property. In summary, we will use the distributive property to multiply the monomial with a polynomial. It follows the same steps as the first time that we were covering this. So if I get over to my right, we need to take the outside term that is multiplying to the parentheses, in this case the 2, and multiply it to every term on the inside. This would be 2 times the y, which gives us 2y, as well as the 2 times the negative 5. Now 2 times a negative 5 gives us a negative 10. Excuse me. Now with this, we are finished. We cannot simplify this anymore, and everything stays the same. We didn't have to change our exponent to our y, and we just multiplied numbers. Our next one shows that we are going to be multiplying by not only a number, but also a variable. We still multiply everything being multiplied on the outside to each piece on the inside. So we're going to multiply the 2x to the x. Now if I look at coefficients, that's 2 times a 1, which is just 2. And then we learn from our last section that x times x means that we are going to add the exponents of x. When we are multiplying the variable, we add the imaginary 1 as the exponent, which makes this squared, x squared. And then we also multiply it to the next term. We have to multiply it to every single term inside the parentheses. This time, there is a number that we can actually multiply by. 2 times negative 6 is a negative 12. And our variable didn't have anything to change its exponent, so it just stays x. So in this case, it is simplified in the sense that we no longer have the parentheses. Now a little bit more complex problem. In this case, we have 2 sets of parentheses, and we're multiplying both of them by a term including a variable. So if we break this down, we can start with the first parentheses. This will be 3x times 2. This will give us 6x. All we did was multiply the coefficients, the 3 and the 2. Then we multiply our 3x with the negative 4x. This time we have coefficients. 3 times negative 4 was, or is, negative 12. And x times x, as we just did a moment ago, is x squared. So that would complete our first parentheses. I made sure that every term on the inside was multiplied by our outside term. Now we need to do this to the second set of parentheses. This time we are going to be using the negative 2x squared and multiply it, distribute it throughout the parentheses. So in this case, we have negative 2 times the 3, which gives us a negative 6. Still a part of that same product. X squared times x. These are the same base, so we add the exponents, 2 and the 1, which is x cubed. And then our last piece, we're still multiplying the negative 2x squared to the negative 1. This only has a number that we can multiply, giving us a positive 2. And we still have the x squared as a part of the term. So when you're dealing with multiple parentheses like this, there's a chance where we still have to combine like terms. For example, we have our, if I write this better, we have an x squared twice in our setup, as well as it's not organized. So we're going to do both of that in the same step. Our highest power is x cubed, so I'm going to write that term first. That is negative 6x cubed. Next would be our x squared, which we have two terms. If I combine these, that would be negative 12x squared plus 2x squared. Since we're adding, this affects the coefficient, the number in front, which will give us negative 10 for our new coefficient of x squared. And then there's nothing to combine the x with, just so that we can see it separately. I'll circle this one so we know that they are different. And it's a positive 6x, so we're going to put plus 6x. So in this case, I added the blue circle only so we can see the separation between every type of our terms, making it easier in the long run. Right now, it was only 2 parentheses, but harder problems are going to get a little bit more complex, and these simple steps help in setting up your problem. The last one that we're going to do together, 3x squared times the polynomial. We take the full term on the outside, 3x squared, and multiply it by each piece. The 3 times 2 gives us 6. X squared times x squared means that we are going to add the exponents of our like base, making it 4, the exponent 4. And we're done with that first term. We now have 6x to the power of 4. We multiply 3x squared to the next term, giving us a positive 12 for our coefficient. And our variable, being like base, is x squared plus x squared times x, which means we're going to add 2 plus 1, giving us a new exponent of 3. So we need to remember that there is the 1 that is known to be there for the exponent. And then our last part, 3x squared times the negative 7 gives us a negative 21 for our coefficient. And we only have the one variable x squared, so we still need to write that down for the term. So this is our next step in using the distributive property. We add in the variable in our distribution with our coefficient. Now, it doesn't always have to have a number. It can also be just a variable. So remember that when we move to our next step, which we'll be doing the opposite, where we factor out our like factors.